The one and only KB, what's up? What's happening? I see you still got your mask on there, eh? I'm well. What's happening? Why are you up this morning? And since you're here first, what's happening? I see you still got your what do they call it? The COVID mask on there on your profile picture. Bring your daughter for school. What grade? Has the daughter written the maths for this term? Because you know what I'm about. You know what I'm about here on this platform. It's just maths. It's always maths. And if you don't mind just reminding me of the grade that the daughter is in. Smart study. Study smart. How's it more? Yeah, those who are here, guys, smart study. The resource is the resource guy. If you guys need resources there, past papers, grade 8 to 12. Smart study is the TikTok channel to follow. I'm doing swell, doing very well. It's good seeing you. Doing very well. What's happening on your end? Oh, she's in grade 9. Neat. Is she written? The one and only KB. Has your daughter written the term exam? I think whilst we're on that flow of things, I think I'm gonna do some grade 9 stuff. Since we are on that tip. I might as well, right? Yeah, hopefully my live sessions are helpful to her. Your daughter, that is. I won't have it any other way. I have no other objective than to help the community. Just a sec, guys. Sorry. Yeah, so guys, this was a paper that was written by the learners in grade 9, I guess, in the part of the world that I'm in. Thank you so much for the roses. So, yeah, this was it. And yeah, you just look at the questions and we try and answer them. So the very first question that's here says determine the gradient and the y-intercept. Term 3, guys, has been linear functions, straight line graphs, and geometry. So I'm just going to look at these questions and I'm going to answer them. So the first question says determine the gradient and the y-intercept. So gradient means the measure of how steep a line is. All right, 4 ways that we can see gradient. Gradient can either be positive, meaning greater than 0, and we usually see a straight line that is like this whenever the gradient is positive. It's an increasing straight line. Gradient can be negative, meaning the line or the slope of the line, it slopes downwards, so it decreases. Gradient can be equal to 0, which means we'll have a horizontal line like this. Here our y value is constant, and then gradient can be undefined, which means in that situation we are going to have a vertical line and our x value is constant throughout that vertical line. So gradient is the measure of how steep our line is. All right, so here we have a positive gradient, meaning it's an increasing function, increasing straight line, because as x increases, y increases. When the gradient is negative, we have a decreasing straight line. When the gradient is equal to 0, we have a horizontal straight line. And when the gradient is undefined, we have a vertical straight line. Okay, so if we come here, guys, it says determine the gradient and the y-intercept of the graphs. Now, in order for us to determine the gradient of a equation of the line like this is what needs to happen. First and foremost, our equation needs to be written in this form. So when our equation is in the form y is equal to mx plus c, we can simply read the gradient. M will give us the value of the gradient, this m. But the equation must be in this form first. Then our c here will give us the value of the y-intercept. So I'm just going to now look at this question and see how we can extract or take the gradient and the y-intercept. So here is the equation. Y is equal to 2x. 2x what? Minus 1. Now, the equation, is it in standard form? Yes. So this is in standard form. So SF means standard form. Here I can read the gradient. The gradient is 2. Then, what about the y-intercept? The y-intercept, I can just say y-int is equal to the what? To the c value. The c value is equal to what? -1. So this is how I identify my gradient from an equation of a straight line and my y-intercept. I simply identify m and identify c. So my m value is 2, that's my gradient, and my y-intercept is equal to the c value. My c value here, you can see, is -1. So that means y-intercept is equal to c is equal to -1. That's my y-intercept. Done with the first one. Let's go to the second question. Determine the gradient and y-intercept of this graph. Once again, I can see this is also a linear equation. Why do I say it's a linear equation, guys? It's a linear function because the x has an exponent that is 1. The y has an exponent that is 1. And then I have a constant value. This is what helps me understand that this here is a straight line equation. So once again, let's come here. Y plus, write down the equation. 2 is equal to half x. Now, is the equation in standard form? No, it isn't. So I'm going to fix the equation and write it in standard form. The y needs to be alone on the left, equal to this 2 is going to transpose or cross over the equal sign and go to the right hand side. It is currently positive. When it crosses over, it becomes negative. So I'm now going to have half x. The 2 becomes -2. Does that make sense? So now my equation is in standard form. I can now identify the what? The gradient and the y-intercept. What is the gradient? The gradient is the coefficient of x, which is half. Thank you so much, Lau, for the 2 roses. The coefficient of x is half, so I'm going to say m is equal to half. That is my gradient. 2, my y-intercept. My y-intercept, y-int, is equal to the c value. And in this current situation, what is my c value? It is -2. So this, guys, is how I write down my gradient. And this is how I write down my y-intercept from this equation. First, write the equation in standard form. Then you identify m, the gradient, and c, the y-intercept. Number 3. Here is the equation. Is this an equation of a straight line? Yes, it is. Why? Because y has an exponent 1, x has an exponent that is 1, and there's a constant value. But is the equation in standard form yet? Well, let's write down the equation. 3y is equal to 6x minus 12. Currently, what we can see, guys, is that the y is not alone. It has a coefficient number, which is 3. This 3 has a relationship with y of multiplication. So how do we get rid of this 3? Okay, this is one term. The 3 is multiplied to y. How do we get rid of the 3? Well, we are going to do the inverse of the multiplication, because 3 has a relationship with y of multiplication. So to get rid of it, we are going to divide by 3. But what we do on the left, we must do with each term in the equation. We are going to divide by 3 here, divide by 3 there, divide by 3 there. Then we are left with y is equal to, okay, because 3 divided by 3 is 1. So the 3 and the 3, they cancel. We are left with y. Alright? Yeah, the 1 is there, but we can't see it, but it's fine. At least the y is isolated. It does not have a numerical coefficient that is greater than 1 or less than 1. Then the 6 divided by 3, that gives us 2. Then 12 divided by 3, negative 12 divided by 3 gives us negative 4. Is my equation now in standard form? Yes. I can now identify m and c, the gradient m, and c, the y-intercept. So now m is equal to what? Here is the value of m. M is equal to 2. That's my gradient. Then c is what? C, the y-intercept, is equal to c, which is equal to negative 4. This is my y-intercept. Y-intercept is equal to c, which is equal to negative 4. The question you're asking, Tabata, is how many marks? It is 2 marks to identify or determine the gradient and the y-intercept. So I have 1 mark for the m value and the second mark for the y-intercept. But in order to identify these, I need to first arrange and make sure that my equation is in standard form, which is very, very important as a grade 9 learner. I hope we are good. I hope we are well. Let's move on to the next question. Let's move on to what? The next question. What is the next question? The next question is the following. The graph of y is equal to mx plus c is drawn below. Here it is. Study the graph and answer the questions that follow. Let's look at the graph. Here is the graph, guys, that they are talking about. Alright, they are saying the first question, write down the coordinates of A. In the comment section, guys, what is the coordinates of A? There is A. Can you guys see where A is? There it is. It's on the y-axis, which means this A is the y-intercept. So we want the coordinates of the y-intercept. Ahlumile Willy says 0 and 10. Okay, do we all agree with Ahlumile Willy, or do we have a different response? Tusha Premdat says also 0 and 10, and Tusha has put in brackets as well to indicate that these are supposed to be encased in the brackets. Okay, guys, you are 100% correct. Ahlumile and Tusha and Tabata are 100% correct. Remember here, our x value on the y-axis is 0. I repeat, on the y-axis, the x value is always 0 here. Everywhere on this vertical line, the x value is 0 because we are having a y-axis that is passing through the origin. Alright, so the x value is going to be 0. So there, guys, very important that A is equal to, right, our x value here is 0, but the y value at this very same point is going to be 10. So our coordinates for the A there will be, as has been said, x is equal to 0, y is going to be 10. Very good. You guys are 100% correct. So the 2 marks there are for 1, 2. 1 mark for the x coordinate and the 1 mark for the y coordinate. Let's go on to the next question. What is the value of the x-intercept? Okay, remember, what is the x-intercept? This is where our straight line cuts or overlaps or crosses the x-axis. Where is the line cutting, crossing, or overlapping the x-axis. What is the value of the x-intercept? And remember guys, they don't want the coordinates of the x-intercept. They want the value of the x-intercept, and that is different. If they wanted the coordinates, Tusha's comment would be 100% correct. Saying 5 and 0 would be spot on. But they wanted the value of the x-intercept. If they want the value of the x-intercept, then we have to then say that the x-intercept is equal to 5. Are we together? Very important, guys. They wanted the value of the x-intercept. It's different if they had said they wanted the coordinates. If they wanted the coordinates, we would write down the coordinates and say that the x value there is 5 and then the y value is 0. But they didn't want the coordinates. They want the x-intercept. So we can say x-int is equal to 5. Or we can say x is equal to 5. That's also fine. So one of these two would be 100% fine to write. But please guys, let's read the question. If they want the coordinates, if they had wanted the coordinates, we would have said 5 and 0. This is the coordinates of the x-intercept. But they want the x-intercept, the value. So we say x-int is equal to 5, or we can say x is equal to 5. This would be the correct way to write our answer. Let's move on. Yes, this is great, guys. Let's move on to the next question. Write down the value of c. Write down the value of c. So the graph of y is equal to mx plus c. They want the value of c. All right. What is the value of c? Remember, the c value represents where the graph cuts the y-axis, our y-intercept. So that c value, yes, Ashumile, very good. C is equal to y. Okay, so that means our c value is equal to y, and therefore the c value, we're going to just say 3. C is equal to 10. That's it. The value of c is equal to what? To 10. Why? Because that's where the graph cuts the y-axis. That is our y-intercept, and the y-intercept is the same thing as the c value. Okay, I hope that makes sense, guys. Very good. Then let's go on to 1.2.4. Is the graph increasing or decreasing? Let's look at this graph, guys. What's happening to this graph? Is the graph increasing or decreasing? Now, it's very shocking that some learners, they think that this graph, does something else than decrease. Very disappointing. Guys, when you are looking at whether a graph increases or decreases, here's the thing. You look at the graph from left to right. What's happening as you move from left to right? So as we move from left to right, you should notice something about the graph. The graph is, I'm going down. I'm going down. As you move from the left to the right, what's happening to the graph? It's going down. Please, guys, as you move from left to right, please, we need to look at the graph from left to right. Then we need to decide what's happening from left to right. Whenever you have to comment on whether a graph is increasing or decreasing, you look at the graph from left to right. So what's happening as you move from the left to the right? The graph is decreasing. Please, guys, decreasing. By the way, it makes sense that the graph is decreasing. Okay? Yeah, please, guys. Otherwise, we're going to have problems here. Big problems if we are making mistakes. All right? It would be very wrong. Look at these people. You grade 9s, you feel entitled. Okay, look at this comment, Leo. Look at Leo's comment. Leo is saying, look at this. Why weren't you live yesterday morning? I wrote the wrong maths yesterday. Right? Leo. All right? Like I said, I think some of you feel very entitled when you are here. Please. Entitlement's not going to serve us here. Right? Yeah. So, Yeah, and me is very busy. Very busy. Me is very busy. Okay, let's go to 1.2.5. Determine the value of m. Show all workings. Alright. So what you can do if you want to determine the value of m, remember, what does m stand for? M stands for the gradient of the equation. Alright. So we need to calculate the gradient. And what we do have here is we can actually identify some of the points on this line. Now some of you will be saying, how can we identify some of the points? Guys, you can. Right? You can identify some of the points on the line. Look at this, for instance. So you can take any 2 points on the line and then use them to calculate the gradient. Remember, gradient has a formula. M is equal to y2 minus y1 over x2 minus x1. Remember this formula? That's how you calculate gradient. All you need are 2 points. Now I can locate any 2 points on this graph and use them to calculate the gradient. Look at this, guys. Do you see, for instance, here? I know what this point is. Okay, the point here, x is 4 here. X is 4 here. And the y value here is 2. So I have 4 and 2. I could use this 4 and 2. Okay, I could use the x value, that is 4, there it is, and the y value, that is 2. Okay, then let's look at another point that we can identify from the graph. There's another point here. Look at that. This x value here is 2 and the y value is 6. So I can use 2 and 6. Okay, you could use these 2 points to calculate the gradient. Or if you are someone else, let's say you decide, I'm going to use the x-intercept and the y-intercept. The y-intercept you already know is 0 and 10. And look at this one. This x-intercept you already know is 5 and 0. So look, I'm going to look at these points and see if I use these 2, do I get the gradient? If I use these 2, do I get the same value? So let's go. This I'm going to say is my first point. So I'm going to say this is x1 and that is y1. As my first point, I say this is x1, y1. Then this is my second point. I say that is x2, y2. Let's go and substitute into the equation and see what we get. So y2 is 6. M is equal to, in the place of y2, I write 6 because that's y2. Then in the formula, there's a minus sign. What about y1? y1 is also 2 over x2 is 2. There's a minus sign in the formula. I write that minus sign. x1 is 4. Then from there, what do I do? What's 6 minus 2? That's 4. What's 2 minus 4? That's negative 2. Then what's a positive divided by a negative? It is a negative. What's 4 divided by 2? That's 2. So that means my gradient is equal to negative 2. Do you see, guys? I simply used any 2 points that lie on this line. Okay, where did I get 4 and 2? This was the point I used. Okay, I simply just went to my straight line and saw and checked which point can I get from the straight line. Any point that lies on the line, guys. Someone else could have used 3 and 4, maybe, and 4 and 2. That's also fine. You'd have still gotten the same gradient. Okay, as long as you are able to locate a point. Look at this one, for instance. That's 1, x is 1, and 1 and 8. You could have used 1 and 8 maybe, and 4 and 2. That would have still worked. Okay, so now let's check if I use A and B, if I still get the same answer. Remember, I already told you that A is 0 and 10. B is 5 and 0. So let's go and identify. So I say this is my first point. This is x1, y1. This is my second point. This is x2, y2. Do I still get the same gradient? Let's check. M is equal to, in the place of y2, I write 0. Minus, in the place of y1, I write 10. Over, in the place of x2, I write 5. Minus, in the place of x1, I write 0. Then, what's 0 minus 10? It's negative 10, guys. Please Please, by now, you should know how to add and subtract integers. If you don't know, please take your calculator and punch this in. 0 minus 10. Your calculator will give you the answer. Please. We can't be messing up addition, guys. We can't be messing up addition and subtraction. 5 minus 0 is 5. What's negative divided by positive? It's negative. What's 10 divided by 5? It's 2. So our gradient there is negative 2. So you can see, doesn't matter which points I use, as long as the points they lie on the line, I can use those points and calculate my gradient using the formula for gradient. Okay, so I hope you understand. Please, guys. Okay, so that's how you calculate gradient. Let's move on to the next question. 1.2.6 says draw the graph of y is equal to x plus 4 on the same Cartesian plane on the diagram sheet. Guys, I repeat, draw the graph of y is equal to x plus 4. Where? On the same Cartesian plane. On the what? On the diagram sheet. Okay. People like Smanyambosho, you see, you are going to delay me, all right? Because I'm going to have to leave at a certain point. So you're saying I must repeat the calculation. Why weren't you listening? Okay. Hi man, Mbosho, you are Mbosho, you see, I was explaining how to calculate. The question says determine the value of m. What is m? M is the gradient of the equation. It's there. All right. How do we calculate the gradient? There's a formula that we can use. M is equal to y2 minus y1 over x2 minus x1. In order to find this y2 and this y1 and this x2 and this x1, where do we go? We go to the graph. Where in the graph? You just go and identify any points that you can see on the Cartesian plane. So I identified, for instance, the x value, which is 4, where the corresponding y value is 2. So that means the coordinate for this point is x is 4, y is 2. Okay? Then I went to my graph and I identified another point, and I came here and I could see here's another point I could identify where x is 2 and y is 6. So there it is, x is 2, y is 6. Then I use the formula here. First, identify my first pair of coordinates, which means this is x1, y1, because I said this is my first pair. And then this is my second pair of coordinates. This is x2, y2. Okay? Then you substitute y2 in the place of y2. That's 6. The formula has a minus. I write the minus sign. y1, sorry. I write y1. It is 2. There we have 6 minus 2 in the numerator. In the denominator, we write x2. Where's x2? It is 2. There it is. I write the minus sign from the formula. Follow it with x1. What is x1? It is 4. 2 minus 4 in the denominator. 6 minus 2 is equal to 4. 2 minus 4 is equal to negative 2. And then you divide the 2. You get m is equal to negative 2. That is the gradient. Okay? Or you can use any other points as long as they are on the line. Doesn't matter, guys, as long as their points are on the line. Okay? Okay, so let's look at the A, which is the y-intercept, and B, which is the x-intercept. A is 0 and 10, whereas B is 5 and 0. There it is. 0 and 10, 5 and 0. I use those points. I could use those ones too. Then, like I said, first point, x1, y1. Second point, x2, y2. Then I substitute in the formula. What's y2? 0. There it is. Minus the minus sign. What is y1? y1 is 10. There is 10. Over x2. What's x2? It's 5. The minus sign. There it is. What is x1? 0. What's 5 minus 0 in the denominator? It is 5. What's 0 minus 10 in the numerator? It is negative 10. What's a negative divided by positive? It's negative. What's 10 divided by 5? It's 2. The gradient is negative 2. If you haven't heard it now, I'm sorry guys, I'm going to have to move on. Okay. This is from a particular test that was written. Okay, so the grid lines are given and everything is fine. So let's go on. Move next question. Draw the graph of y is equal to x plus 4 on the same Cartesian plane on the diagram sheet. Guys, if you are going to draw this graph, y is equal to x plus 4, We can do so by using the dual-intercept method, or we could use the point by point. Now, since we already have grid lines, it's so easy to just use point by point, so that we can just make sure that everything is 100% muchocho. So the graph of y is equal to x plus 4. For instance, if I'm going to substitute 0 in the place of x, 0 plus 4 gives me a y value that is 4. So I know that this graph has a point that is there. Let's substitute 1. What about substituting x in the place of 1? I mean, substituting 1 in the place of x. What's 1 plus 4? That gives me 5. So that means my y value is 5 when x is 1. So when x is 1, my y value is 5. You see? I can substitute 2. Let's substitute 2 here. What's 2 plus 4? In the place of x, we substitute 2. What's 2 plus 4? It's 6. So that means when my x value is 2, my y value is 6. That's there. Okay? So the point by point, when x is 3, what's 3 plus 4? It gives me 7. 3 plus 4 gives me 7. So there it is. Okay? Okay. Yeah, I hope that makes sense. Then we could do the same thing, obviously, for the negative values. When x is negative 1, negative 1 plus 4, that gives us positive 3. So when x is negative 1, y is positive 3. So that's that point. What about negative 2? Negative 2 plus 4. 4 minus 2 gives us 2. So when x is negative 2, y is positive 2. There it is. Do the same thing with negative 3. What's negative 3 plus 4? Negative 3 plus 4 gives you positive 1. So positive 1 when negative 3, when x is negative 3, y is positive 1. And then last but not least, when x is negative 4. Negative 4 plus 4 gives you 0, guys. So when x is negative 4, y is 0. We are there. Then you can take your ruler and connect these lines, guys. You will have a beautiful straight line there. Beautiful straight line. You use your ruler, you use your pencil, you connect, guys, and you draw that line. Arrow on the one end, arrow on the one end, to show that it continues on forever and ever. And you can see where the two lines, they cross each other. We call this the point of intersection. Point of intersection, where the two graphs, they cross each other. Point of intersection. What is that point of intersection? When x is 2, y is 6. The next question says, use the graphs to find the coordinates of the point where the two graphs cut each other. Where they cut each other at 2, where x is 2, where y is 6. That's where the two graphs, they cut each other. So by writing 2 and 6, 100%, 2 marks. Okay. See at the leg, if you didn't add the other points, that's fine. All right. Some of you may have drawn this graph using the dual-intercept method. All right. But now, after you use the dual-intercept method, you would have taken your straight line, your ruler, right? You would have found your x-intercept, right? How? You let y be equal to 0. Okay, you would have come here to the equation. You let y be equal to 0 because you would have used the dual-intercept method. 0 is equal to x plus 4. You would have done this, right? Then you solve for x. You take the 4 over. You get x is negative 4. Then your first point there would be negative 4 and 0. Remember, you let y be 0. You substitute in the place of y 0. And then you took the 4 over. So it's x is equal to negative 4. So when x is negative 4, it was when you let y be 0. So that's your first point. Then you let x be equal to 0. If you are using the dual-intercept method, go to your graph. Y is equal to, in the place of x, you write 0 plus 4, right? What's 0 plus 4? Y is equal to 4. Then you write your coordinates. When x is 0, y is 4. So this is the dual, it's the intercept method that you are using. But remember, when these 2 points, you've identified them, now we must go to your Cartesian plane and identify these 2 points. So what's 0 and 4? 0 and 4 is there. you would mark that point. What is negative 4 and 0? Negative 4 and 0 is there. You identify that point. You take your ruler, you place it like this. You connect those two lines. When you connect those two lines, if you draw, you will see that the line will still be the same. And it will pass through where the two lines intersect, that 2 and 6 still, if you use the what? The dual intercept method. So point by point, as you've seen me do, you could have used, or you could have used the dual intercept method, but make sure that your straight line goes right across the intercept and right across the other line so that you can see where these 2 points, 2 lines intersect. Okay? It intersects at 2 and 6. So that is the first 18 marks of this paper. Done, finished. Okay, so that was, that paper. All right, now let's move on to the next question that was asked in this question paper. Okay. Question 2. Look at this question. In the diagram below, AB, there it is, intersects CD. Okay. AB intersects CD. You can see this line cuts this line, so that's good. That's what the word intersects means. At what? At G. There it is, G. Then we are told that BDE is a straight line. There it is, a straight line. And FE is drawn. FE is drawn. Then we are told angle B is 59 degrees. There it is, guys. They've already put in the 59 degrees for us. Angle G2 is G2. G2 is 31 degrees. There's the 31 degrees. It's already put in there. There's the 2 to indicate G2. Angle G2 is 31 degrees. Then we are told reflex angle E. What is a reflex angle? A reflex angle is an angle between what? 180 and 360. Where's reflex angle E? There it is, here. It's 239. So it makes sense that it is a reflex angle. Then we are told angle C. Where's C? CDE. There it is, guys. Makes sense. Okay, is X. And the first question is, determine with reasons the size of angle G4. Where's G4? There it is. So what is angle G4, guys, with reasons? Very good, Ahlumile Willy. Angle G2 is equal to angle G4. What's the reason? Vertically opposite angles. Hopefully we all see that. Angle G2 is equal to G4. There, but that is 31. Okay. Let's be very careful about that. So yes, you guys are 100% correct. G4 is equal to angle G2, which is equal to 31 degrees. The reason, vert op angles equal. That's the reason we find in the acceptable reason document, vert op angles equal. Okay, I hope we're good. Then whenever we get something, we must update our diagram so that our diagram has the represented new information, so that when we move on to the next question, we can also note what we have found. Let's go on to G3. Angle G3. What's angle G3, guys? Here's G3. G3 has a relationship with G4 because they are angles that are on something. Also, G2 and G3 also have a relationship because they are angles that lie on something and they share a common vertex. Okay, so hopefully we can see that angle G3 and G2 are angles that lie on a very good Siateleki, on a straight line. Also, if you want to look at it in another way, angle G4 and angle G3, because you know what angle G4 is, and G3 also, they lie on a, exactly, guys. So angle G3, as you guys have beautifully mentioned already, okay, when we do the working out, we usually say, or we usually approach it in the following fashion. We would say angle G3 plus angle G2 is equal to 180 degrees, and we'd say angles on a straight line. Okay, then obviously angle G3 is what we want, angle G2 is what we have. All right, and then we can solve 180 minus 31 degrees. That leaves us with angle G3 being equal to, as you guys have beautifully said, it's 149 degrees. So our statement is everything here. Our statement and our reason and our answer is everything. Okay? We state angle G3 plus 31 degrees equal to 180 degrees, angles on a straight line, and then we solve, we get G3, angle G3 being 149. And guys, once the answer is correct, we can go and update our diagram 149 degrees, so that when I look at my diagram again, I look at it with that information filled in. Okay, so yes, angle G3, one could do this. Angle G3 is equal to 149 degrees and simply say angles on a straight line. This would also yield the required amount of marks. But I hope you guys understand the process though, that angle G3 plus 31 degrees is equal to 180 degrees. Reason, angles on a straight line, and then we solve, we get angle G3 being equal to 149. Look at the next question, guys. Prove with reasons that CD is perpendicular to BD. Now we must locate CD first. Where is CD? Here is CD. Okay, where is BD? There is BD. We are being asked to prove that CD is perpendicular to BD. What does that mean? It means we need to actually find out, or in some way indicate, all right, or prove that angle D1 is 90 degrees. All right, now what I can see, guys, from the diagram is I can see there's a triangle here, triangle BDG. Do you guys see triangle BDG? Can you see triangle BDG? Can you see that? I already have an angle there, which is 59 degrees. And you remember I updated my diagram and found angle G4 and said it's 31 degrees. Do you now see how important it is to get an answer and update your diagram? Because when I've updated my diagram, now I can see, oh, 59, 31, angle D1. Let's solve for angle D1. We have a triangle. So let's go and solve that. Okay, let's go and see what we get. So in triangle BDG, I tell my teacher which triangle I'm working in, so that my teacher, when he reads my work, he can say, oh, this learner has identified that triangle. I can then say, there, 59 degrees plus 31 degrees. Where is the 59 and the 31 coming from? Remember, these are the angles, 59 and 31. 31 that I found when I was doing the previous question. So this 31 and this 59 plus the angle what? Angle D1 is equal to what? 180. Why are we saying that the three angles, they add up to 180 degrees? Kaloku, we know interior angles of triangle. Acceptable reason document. Or if we don't want to use that reason, we can always say sum of angles in triangle. Acceptable reason. Or if we don't want to use that reason, we can always say angle sum in triangle. Guys, you only have three options for the acceptable reason document. For all my grade 9 learners that are going to grade 10 next year, and you want to make sure that you're always writing the reasons the way that is acceptable, one of these three always works. Okay, so that's fine. Now we can solve for angle D1. Let's go. Angle D1 is equal to 180. Now we take the 59, we transpose it. Minus 59 minus 31. What do we get? Surely you guys can see. If you don't know how to add in your mind, please use your calculator, and please be accurate when you write down the values in your calculator. Guys, what does angle D1 become? What is angle D1? I'm going to wait in the comment section for the answer, because getting that angle is key. Once you get that angle, game over. Game over. Checkmate. Thank you, pretty boy. You are so pretty. You are so pretty. You are pretty in the maths now. Praise the Lord, praise the Lord, praise the Lord. Leila, thank you so much. So angle D1 is what? 90 degrees. So what does that in essence mean, guys? It means D1 is 90. Remember, if angle D1 is 90 degrees, what does that mean, guys? It simply means that we can conclude and say CD is what? Is perpendicular to BD. We can conclude that. So I'm going to say, therefore, CD is perpendicular to BD. Why, guys? Why is that the case? All right? It's because I found right angle. There. You see, I found a right angle there. Yeah. Or, I mean, it would be fine to even say, right angle. Right angle. D1 there is a right angle. Angle D1 is equal to 90 degrees. I mean, we could say that if you say CD is perpendicular to BD and you say angle D1 is 90 degrees, that would be 100% correct for your reason. Okay? Or you could say the right angle. That's why we say CD is perpendicular, because when we get 90 degrees, it means those two lines are perpendicular, no doubt. So that's what we needed to do to prove that the two lines are perpendicular for 4 marks. Okay, for 4 marks. Let's move on. So I update my diagram. I put the 90 there. I put the 90 degrees. I put it. It's there. The box means 90. Next question. Prove that AB is parallel to FE. Where's AB? AB is here. Where's FE? FE is there. We need to prove that these two lines are parallel. Now, guys, 3 ways to prove lines are parallel. Either you find alternate angles that are equal, if possible, or you find corresponding angles that are equal, or you find co-interior angles that are supplementary. It's one of 3 things that you need to identify. Now, check this out. If you look at these 2 lines, what is in between? Is there a Z shape that you can see somewhere here for alternate angles? No, I can't see any Z shape. I can't see Z here, no. F shape maybe? Okay, no, I can't see F shape. U shape maybe? Yes, I can see U shape. Where? Here, guys. Okay. There. So if in some way I can find out that this angle plus that one is 180, then I can conclude that these 2 lines are parallel. So let's see how we can actually get there. So what I need now is this angle. I need to find out what the value of this angle is. Angle FEB. I need to find what this angle is. Okay. And this is what I'm going to do. FEB, this angle, FEB, plus my reflex angle E will be equal to 360 degrees. This angle FEB plus the reflex angle that I had spoken to me about, which is 239, should all add up to what? 360 degrees. What's the reason? Angles around a point. Or sometimes you can use angles in rev. Okay, those are the 2 acceptable reasons that they actually allow us to use. Now, what's angle FEB? This is what I want to find. What's the reflex angle E? It is 239 degrees. Now I'm going to solve for this angle. Take the 239 over, subtract. So angle FEB is what, guys? What's angle FEB? angle FEB is equal to? I need someone to let me know in the comment section. What's angle FEB? 360 minus 239. Thank you, Mr. Hambe. Alright, hopefully we are all agreeing. Yes, 121. There it is, 121 degrees. So I go and update my diagram. 121. I'm accurate, Moss. I know I'm accurate. Now, let's check. I want to verify now. ABE plus FEB, angle FEB, angle ABE plus angle FEB. What does it actually give me? ABE is 59 degrees, that angle. Okay, plus FEB, 121 degrees. What do I get here? 180. Huh? These two angles are what? They are co-interior angles. They are. The addition of both of these angles gives me 180. So what can I conclude about these two lines then? AB and FE. Alright, what can I conclude? I can therefore conclude that AB is parallel to FE. What's the reason? Co-int angles supplementary. These co-interior angles are actually supplementary, and that's where it ends. Why? Because I am proving that these two lines are parallel. So the reason that you use is co-interior angles supplementary, finished, full stop. Remember guys, when you are proving lines, if you want to prove that lines are parallel, this is one of three ways to prove it. You can either prove that alternate angles are equal, or corresponding angles are equal, or co-interior angles are supplementary. In this particular situation, we were able to prove that the co-interior angles actually do add up to 180 degrees, and therefore these two lines are in actual fact parallel. Okay, so because they are, we say the reason is because co-interior angles are what? Are supplementary. These are the two angles that are supplementary, which are co-interior, that we found, that validate that AB is parallel to FE. Okay, yeah. So please guys, how do we prove lines are parallel? One of three ways. One of three ways. We can either prove alternate angles are equal. Now, I did not even look in the direction of alternate angles because from this diagram, guys, there's no Z shape that I can see. There's no Z effect that I see in the diagram. So I discounted alternate angles being equal. 2, what about corresponding angles, the F shape? I discounted F shape. Why? Because in these two lines, I can't see an F, right? If, for instance, this angle, all right, this line, all right, there's no other F, yeah, I hope that makes sense. Okay, so co-interior is inside, together, inside the lines. That's co-interior. Okay, I'm moving on now, guys. Write down the value of x. They're not saying solve, they're saying write down. Remember, I got 90 here. So we're told that BDE is a what? Is a straight line. So what is the value of x here? If that is 90, guys, and this is a straight line, what is the value of x? Simply put, x is equal to 90 degrees. I hope you see that. And what's the reason? Angles on a straight line. Simply put. Please, guys, I mean, we just write down the value as they are saying. Write down. We are writing it down. Okay. I hope that makes sense. Last page question. Question 3. All right, which was for this paper, consider the quadrilateral ABCD below. BDB, where's DB? DB extends to E. Right? AB is what? Parallel to LM. And BD is equal to BC. Now, because I'm the person that I am, when they are saying that, that simply means that these two lines are equal. So I'm going to write the symbols to indicate that BD is equal to BC. They did not insert these two lines, but I'm going to put them in so that it can serve as a reminder for me when I look at the diagram that these two lines are equal. You can see this is a triangle, so already you are thinking of the what type of triangle? An isosceles triangle. And already there are things that are going off in my head about that idea. BD being equal to BC. Angle B4, where's B4? There's angle B4, is 67, it's in the diagram, 100% good. Angle C, where's angle C? There's angle C, 72 degrees, it's already in the diagram. Angle ADC, let's move with the lines. ADC is 120 degrees. From here all the way to there is 120 degrees. So everything in the statement I can see represented in the diagram. AB being parallel to LM, you can see the two arrows to indicate lines that are parallel. And the only thing I had to add onto my diagram is the fact that since BD is equal to BC, I just make sure I write these lines to indicate the sides being equal. So I think we are good to now answer the questions that follow. 3.1. Determine with reasons two other angles equal to x. Now, let's first go and see where x is at the moment. Here is x. There is x. Now, they want us to identify two other angles equal to x. When you are doing geometry, guys, do this for yourself. Take your diagram, move it around. I want you to tell me what other angles do you see in the diagram being equal to x? Based on what you are looking at. We have two lines being parallel. So surely you should be seeing some things. What can you see, guys? What do you see? MJC, very good. Angle L3, you are saying is equal to what? To x. Very good, MJC. I love it. MJC is saying some things. Okay? And then someone else is saying angle L1 as well is equal to x. Alright? Now, very important, we need to write down and then we need to give the reasons as well. So I see we've located the angles. Yeah, using what? As you said, fun. So yes, okay, the first thing we can see, or the first thing we will say, is that angle L3 is equal to x. What is our reason? No, MJC, we don't say corresponding angles are equal. No. Be very careful now. We are not proving that lines are parallel. Remember, we use corresponding angles are equal as a reason when we are proving lines are parallel. Now we are identifying an angle with lines already being parallel. So angle L3 is equal to x. What is the reason, guys, that we write? We say corresponding angles, and then we identify the lines that are parallel. What were the lines that are parallel? AB is parallel to LM. You must write down the lines that are parallel. AB parallel to LM. There it is. Angle L3 is equal to x. Okay. Now after that, you can also say angle L1 is equal to x. Okay. If you first identified angle L3, you will say angle L1 is also equal to x. Why, guys? Some of you can see the Z, right? The Z effect. Look at that Z shape. There it is. This angle will be equal to that one. Some of you, after identifying this one, you'll be saying this angle and this angle are equal. So there's two reasons. If you first identified angle L3, you could say angle L1 is equal to x as well. Reason, alternate angles. Then you state the lines that are parallel. Or you could say angle L1 is equal to angle L3, which is equal to x, vertically opposite angles equal. That's also fine. Okay, so if you say alt angles, then you state the lines that are parallel. AB parallel to LM. You are spot on. Guys, let's not forget, if you don't write the lines that are parallel, you can be penalized. You must write alternate angles, and then you must state the two lines that are parallel. Corresponding angles, you must state the lines that are parallel. All right? Please, please, please. Now me, I like updating my diagram. The minute I find something, I put it into the diagram so that when I look at the diagram again, for my next question, I have values already there, or letters, okay, already there. Let's move on to 3.2. Determine with the reasons the following angles. Let's underline this part. In terms of x. Guys, terms of x. Your answer must have a term which is x. Your answer must have in it not just a number, but a variable. You guys in term 1 and term 2, you learned about terms in an expression. So when they say determine the reason the following angles in terms of x, they are saying you must get the angle, but it must have x in the mix. You must have a term in your expression, in the answer, that will have x. So angle L2, where's angle L2? Here is L2. What relationship does angle L2 have with the x? This one. Or you could look at angle L2 with the relationship with this x. What are these angles together? These ones, angle L2 and L1. Let's look at L2 and L1 first. If you look at angle L2 and angle L1, aren't they angles next to each other or adjacent to each other? And aren't they angles that are lying on a straight line? Yes, guys, Junior 10, these are angles lying on a straight line. If you're looking at angle L2 and angle L1. So can't we say this? Angle L2 plus angle L1 is equal to 180 degrees. Hey, my daughter, these people reason angles on a straight line. What is angle L2? This is what we want. What is angle L1 at the moment? It is x, which is equal to 180 degrees. Then you solve. You take the angle, the x over to the other side. So you have 180 degrees minus x. Hey, people, remember, what did the question say? Determine with the reasons the following angles in terms of x. Look at this, guys. What are you seeing in your answer? You are saying 180 minus x. How many terms are in this expression? There are two. The one term is 180 degrees. It's a numerical angle, a number. The second term is x. This is exactly it. This angle L2 is in terms of x. One of the terms in the expression is x. This is what you want. And this is what they wanted you to find by finding angle L2. So angle L2 is 180 minus x, guys. That's what it is, money. And the reason is angles on a straight line. Are we together? So this, be very careful when they ask you a question where they are saying write your angle in terms of x. Be very careful. So now I update my diagram, 180 minus x. Okay, be very careful. Let's go to angle D1. They want angle D1. Also, they want angle D1 in terms of what? In terms of x. Where's D1? There is D1. It's this angle. All right. Now be very, very careful. Very careful, guys. Very, very careful. Angle D1 in terms of what? In terms of x. Okay. So we want angle D1 in terms of x as well for two beautiful marks. Okay. So how do we find angle D1? in terms of x for 2 beautiful marks. Look at this triangle ABD. I'm sure you can see triangle ABD. What do you have? D1, you have 67, you have x. So let's go ahead and say angle D1 plus what? Plus 67 plus what? Plus x is equal to what? 180 degrees. Angle D1 plus 67 degrees plus x. This is a triangle DAB. Angle D1 plus 67 plus x is equal to what? 180 degrees. What's the reason? Interior angles of triangle. Or you could say sum of angles in the triangle, or you could say angle sum in triangle. Yes, MJC, that's very good. Then you solve. Take the 180, take the 67, 180 minus 67 minus x. In terms of x, guys. What's 180 minus 67? 1 what? What is it, guys? 180 minus 67. 113. So our angle D1 is 113 minus x. In terms of x, guys, in terms of x, look at your angle. It's 113, your first term, your second term has x in it. This is an angle in terms of x. No, Sia, you must simplify. You have to simplify. You can't not simplify. You must simplify. So this here is 113 minus x. Reason, int angles of triangle. Okay, so these are our steps to getting to the answered angle D1, and these were our steps for getting to the answer of angle L2. And it makes sense, guys. I hope we all understand. Okay, all right. Hey, I hope we could. I fill in 113 minus x. I fill in that information for myself. Okay, let's move on to the next question. Guys, I'm going to wrap up because I have a few minutes before I actually have to leave soon. 3.3.1. Determine with reasons the size of angle D2. Where's angle D2? This is angle D2, this one. Determine with reasons the size of angle D2. Now you will remember, guys, I said we learned that BD is equal to BC. What type of triangle? Isosceles triangle. That means angle C is equal to angle D2. Angle C is equal to angle D2. D2 is equal to angle C. Can you see that? Angle C is equal to angle D2. Why? So they are equal to 72 degrees. Reason, angles opposite equal sides. That is 72, guys, degrees. Update. Angle D2 is equal to angle C. Remember, we were told that these two lines are equal. We don't write isosceles triangle, guys. We write angles opposite equal sides, because remember, this is an isosceles triangle, I agree, but our acceptable reason is that these two angles are opposite sides that are equal. You see? So we must write angles opposite equal sides. That's angle D2. Let's move on to angle B2. I'm finishing off now, guys, wrapping up. Angle B2, what's angle B2? Here is angle B2. They want me to find angle B2. Now, I'm sure you guys can see that this angle C and this angle D2 are the two interior opposite angles, and this is my exterior angle. Let me take the diagram, and this angle C plus this angle D2 gives me this exterior angle, because this is in line with the side of the triangle and it's an exterior of the angle, this triangle. Okay, so that means these two interior opposite angles, angle C plus angle D2. I repeat, angle C plus angle D2. Angle C plus angle D2 is equal to angle B2. What's the reason? Exterior angle of triangle. Angle C plus angle D2. So 72 degrees plus 72 degrees is equal to angle B2. And then what's the addition of the two? 144 degrees. So angle B2 is 144 degrees. Simply put, I update my diagram 144 degrees. And then lastly, guys, the last question, they want me to solve for x. Calculate the value of x. Calculate the value of x. Okay, and in order to do that, calculate the value of x, I'm sure you guys would know what you need to do in order to calculate the value of x. There's actually a few ways that you can do that. You could either add x plus 67 plus 113 minus x and say it's equal to 180 and then solve for x, or you could take these two angles together, these ones. Okay, yeah, because you know that angle D1 plus angle D2 gives you 120. I repeat, angle D1, you already have D1 in terms of x, it's 113 minus x, plus angle D2, which is 72. The addition of the two gives you what? 120 degrees, and then you could solve for x. So I'm going to show you that angle D1 plus angle D2 is equal to 120 degrees. This total is 120. D1 you got is 113 minus x. D2 you know is 72. The total is 120. So I'm going to say D1 113 minus x plus D2, which is 72, is equal to 120 degrees. Okay, there's no reason besides the fact that this is something that's given to me, so I can just say that. Okay, I mean, that's given to me. Angle D1 plus D2 being 120 is something that's given to me. Okay, there, it's given, guys, it's given, because remember we were told that ADC is 120, which means the ADC is 120, so it's given to you that that's 120. I'm adding just the two angles of the total angle to get 120. Okay, so it's 113 minus x plus the 72 is equal to 120. So let's go and solve nicely. So this is negative x is equal to 120 minus 72 minus 113. Let's go ahead and solve, guys. Negative x is equal to, you just subtract all of this and then you tell me what the answer. There should be a negative something. Come on, go ahead. I trust you. You guys can help me out. Negative 1. What is it, guys? 120 minus 72 minus 113. Negative 65, thank you. And then you divide both sides, guys, by a negative 1. So you get x is equal to what? 65 degrees. So there it is, x is 65. Okay, guys, that was the entire paper. Thank you so much for joining in. I really appreciate it. I hope you guys have a good one. Those who are writing, all the best. Grade 9, if you're writing grade 9. If you're in grade 10 and you're writing today, all the best. If you're in grade 11 writing today, all the best. If you're in grade 12 and you're still preparing for your final exams, you guys have less than like 40 odd days to actually prepare for your final exams, and I hope you will prepare very well. If you are in varsity and you are studying and you are like regretting why you didn't join my live long time ago, you could have passed with a bachelor, well, hopefully that will actually be encouragement for those that are here, that are joining in for the first time. It will give them reason to follow. and be part of the revolution. Guys, I will be having sessions moving forward to also help build foundation for those who want to do maths in grade 10. If you're in grade 9 and you want to do maths in grade 10, please continue to follow. When I do live sessions, in this platform particularly, I'll be doing live sessions for grade 9s, and there'll be a time when I'll have sessions for grade 9s, preparing them for grade 10 next year, so that when you are there, your level 7 becomes a no question. Getting 90 and above, 95 and above, 100% even. 100% is such a possibility when you're in grade 10 if you just understand the basics that you've learned in these grades here down below. Thank you so much for joining in. Love you, love you, love you. God bless you. You stay blessed. And yeah, have a great day. Thank you, thank you. Welcome, welcome.